welcome to the session. Welcome to this interesting discussion. As you said, I'm head of sector IoT. You heard my director, who orchestrates across different important European policy files, which have to be implemented. You heard my head of unit, with this ambitious vision, which also has to be implemented. And I'm head of sector of Internet of Things. And Internet of Things platforms, I think that was one of the main targets we had under the industrial strategy as well. I think Internet of Things platforms were simple, because most of the platforms move data to the cloud. So you solve the interoperability issues like that. And there's still, we have a lot of fragmentation. Today, the Commission talks about a data strategy, a data space, a cloud infrastructure, AI governance. I think the framework was published today. And tomorrow, we talk about IoT in edge and system design. So, and that is a bit, it changes, it's a complete game changer for what we did so far for the IoT community, but also for the unit. And we have to think about the new level playing field. Max mentioned the fireside chat. So not surprising, Europe has leadership in system integration. And then system integration was brought up as a key topic in the fireside chat. I think that's quite obvious. And that's also the topic of the next panel. And I'm happy to welcome three speakers in the panel. I think I will invite one by one to present, to make a short position statement, and then we enter into the discussion. I think we may start with Peter Hermans. Peter, I know you quite a while. You were formerly CTO of Stettin, a distribution system operator in the energy domain in the Netherlands. And you have many activities at the moment at European level and relevant associations, the ETSO, STATEC, Euroelectric, and SOE, this association of grid operators on different sites, but also, your special topic on the TSO-DSO cooperation. This said, I'm very happy to have you here over here. And we'd like to know, looking at this new wave of new challenges of system design on the one hand, new opportunities coming from the grid edge. What is your view? What is your position? What are the main pain point challenges you see in your sector? Peter, the floor is yours.
Thank you, Rolf. First, try to start my screen. Is this visible?
Yes, all good, Peter.
Well, good morning. Thank you, Rolf again. I feel very honored to be on the panel, and actually I've been asked by Rolf to address three questions, which you see here, from the energy sector perspective. The first one is, what are the most important trends and emerging concepts that drive the development of IoT and edge computing? And the second one, I think that's a very important one, which I will address. What does it mean for the energy sector? And the third one is about innovation. Where do you see Europe in the innovation domain, and how can European actors compete with global players? Let me first start with the first question. The first question: what are the most important trends and emerging concepts? A general trend in our society, which I would like to mention first, is that markets work for the society. I think COVID-19 showed this very clearly, and I think it's important to consider this context when we are looking for relevant cases to make a successful introduction of IoT and edge computing. Actually, I would say ride the wave. Next, well, we see the emergence of the platform economy and the build of digital ecosystems. Should we go for centralized solutions, or should we go for decentralized solutions? Actually, if you address this from an economic point of view, it's actually about, do we share welfare, or do we go for the winner takes all? And I think the EU data strategy clearly signs that the latter is not the preferred way to go. And then, of course, bear in mind the driving needs. A digital business ecosystem requires openness, access to data and APIs, cloud to cloud, edge to cloud, and they should always be based on open standards. So standards create the market. And of course, IoT solutions also have to fulfill needs such as latency, resiliency, compliance to increasing privacy regulation. I missed that aspect a little bit in the fire chat report. And geopolitical tensions drive cybersecurity requirements. Very important, as IoT is about automating behavior of our machines in industrial processes, or, for example, in the Netherlands, keeping the water behind the dike. And finally, we need to recognize the importance of cross-sector integration when building a digital business ecosystem. Our economy is not built on silos. Trend to actions. In the Netherlands, we recognize this actually, and we already took the first steps in creating and implementing a cross-sector data sharing framework. In the Dutch, we call it afsprakenstelsel, so probably that will be the next to Heineken, the most important word for the next coming years in Europe. Now, what does this mean, an operating system at the edge? What does it mean for the energy sector? First, a few trends here. I think it's no surprise that the energy transition and the European Green Deal, that they are the driving mission. Massive decentralization of renewable generation is driving actually intelligence to the edge. We're transforming to a complete new energy system. And this will require an integrated approach over energy carriers, electricity, gas, heat, sectors, and governance levels. Actually, what I sometimes say, we are in a perfect storm where digitalization and energy transition meet. Intelligence at the edge means also data at the edge. And that also means that we have to take into account data privacy. Commitment of the end customer for a successful energy transition is essential. And trust on data collection and data processing is crucial. Commitment is built on trust. So the customer will need to become fully in control over his or her data, representing his or her role and responsibility in the future energy system. Then what does it mean in the context of IoT and edge computing? The future energy system will be fully data-driven and will have to be designed from an overall perspective. As I said many times in conferences, the energy system of the future will not be built on the silos of the past. So we should get rid of the traditional discussions of data before the smart meter or data behind the smart meter. And the energy sector should cooperate with other sectors like the automotive or building sector. Recognize that an electric car is not only an electric car, but is an important element of the energy system of the future. This means also that we have to shift our focus from who holds the data to who should have access to the data. And this requires a market neutral role for organizing this sharing of data. A very important element. And then in the energy sector, we still have to do some homework. How to translate the unbundling, which took place many years ago, to the digital space. How to govern the digital twin or digital twins of the energy system, and who has access to which data and which services, and based on which agreements. I refer you back to the Dutch afsprakenstelsel, where we took some first steps in that. And of course, this all with system operations to remain as a neutral service. I think it's clear that IoT and edge computing are a must for realizing the goals of the Green Deal. The energy system of the future will require demand response, processing of real-time data, EV integration. In the Netherlands, we have the discussion on multiple actors on one connection active, new wide area network protocols, etc., etc. This will not be possible without IoT and edge computing. And I think, I talked that to Rolf as well, it would be very wise if the European Commission would send a strong signal to the member states in stating that the next upgrade or version of smart meters should not be a smarter copy of the existing smart meter, which should be really based on IoT and edge computing architectures. My last slide. Where do you see Europe in the innovation domain? How can European actors compete with global players in the emerging cloud edge IoT ecosystem? For me, that's clear. Only the end result counts. And that is a clear achievement, clearly contributing to the Green Deal. So I reflected a little bit on the current innovation situation. I found some root causes, you see them here. And from this, my advice on how to become really competitive on global level is strongly dependent not on individual European actors, but on how they play together and make it as a good sounding orchestra, with the European Commission actually being the director of this orchestra. So my recommendations would be, first, connect clear and explicit cloud to edge objectives to the Green Deal mission. Manage it as a mission. Get the governance right at all levels. I work on European level, on national level, and on local level, and I see so much misalignment that there's a real challenge for improvement there. Involve all key stakeholders. When I come to Brussels, I see a lot of experts in the rooms, but I think the executive should show up as well. Focus on the change strategy and change process. Sometimes we talk too much content, but we talk too less about change and the change process. Make an action plan. And then stimulate public-private cooperation. I think it was said before already by Max. Actually, public-private cooperation, which goes beyond projects, especially when we talk about DSOs and telcos, and when we talk about edge computing connectivity. And finally, and not last but not least, enforce and demonstrate cross-silo and agile way of working at all levels, at European level, national level, and at local level. So the success factor, to my opinion, would be real collaboration, and which really should go beyond doing research and innovation projects. And that should be our man on the moon mission for us all. Thank you. This afternoon, I will be present in the parallel session to discuss as well. Thank you.
Thank you so much, Peter. I think there are many relevant points. I think I recap, particularly, that it requires sort of a very dynamic orchestration at the edge to have a new level playing field, particularly for the energy, because the challenges are not coming from the silo, cannot be built on the silos of the past, but we need sort of a new level playing field across different sectors and across different challenges. With this said, I started off with IoT platforms, and in the industrial strategy, I think we had a very prominent role of manufacturing, and we had an IoT platform like MindSphere, but unfortunately MindSphere was ported to one of the US providers. But manufacturing is still one of the European strengths. So what is the role of edge computing? Is it a game changer, or are we following the line what we had in the past? And I would like to invite Wolfgang Leindecker from TT Tech with his views on the industrial automation. Wolfgang, you are a technology leader in industrial Internet of Things. You are part of the board of TT Tech. You know the business pretty well, and you also have experience from the telecom side or the communication side. So maybe you also expand on the role of telecoms at the future edge computing and manufacturing. So please, Wolfgang, the floor is yours.
Thank you very much, Ralph, for having me. Let me just share my few slides, and they should be coming up now in a second. Yes, let's zoom into specifically the industrial automation space in the production floors, manufacturing floors. And what edge computing can do here. I want to start very non-technical with customer requirements and pain points today. Just real brief, because that's the ultimate goal, what we need to address. Looking at that, I mean, on the shop floors of this world, it's always about optimizing production, OEE, like, constantly optimizing, and edge computing and the platforms, the respective, can do a lot here in further optimizing it and creating new ways. It's about reduction of cost, and here specifically I would mention also consolidation of the the devices, the equipment out there, edge computing can help to consolidate many different pieces of hardware on the shop floors, the control units, hardware, the data collection gateways, and the IPCs, and everything can be condensed onto server-like platforms on the local edge. It's about vendor independence. One of the biggest issues on the shop floors today, and the real pain point for customers, is that they can decide upfront on an ecosystem, but ecosystem means basically something driven by one big vendor, and then they are somewhat locked into that ecosystem, and that is great. Everything works within that vendor in the ecosystem, but it's really vendor controlled. And if you get a machine out of from a different ecosystem, then it doesn't work. So that's really something that needs to be addressed, and that's a big pain point. And then two more I'd like to highlight: brownfield. Legacy systems, never touch a running system, old software, old operating systems that are not even supported anymore. And edge computing can provide a very easy way of migrating that into a new managed ecosystem and orchestrated ecosystem. And the last point I'd like to touch upon is security, specifically the shop floors of this world, the OT world, as we call it, the automation space, is still very far away on the updates from the update cycles that we know in the IT. You know, the regular updates that you need to do, the patches that you need to do from a security point of view, it's very difficult to be rolled out in an environment where you have to go to each and every instance with the USB stick to update it. So edge computing infrastructures or remote deployment infrastructures can do a great job here in addressing that. Now let's jump into a little bit into the technology and what's important on edge computing for industrial IoT. There are three technology building trends that actually come together in the industrial edge and that play a big role. So the first one is convergence of infrastructure, the boundaries between the automation world, a totally separate network, totally separate world for the last 50 or so years, and the IT world are actually blurring. So they are coming together, and that opens up a huge space of new innovative services. And thanks for referring to my past in the telco space. Actually, what I've seen here 20 years back was voice of IP coming into the game. You had telephone systems, enterprise telephone systems, completely separate from your IT networks, email system, and so on. And the blurring, the dissolution of the boundaries, the creation of one ecosystem, one network, actually allowed for a lot of innovation. For example, also these remote web conferences that we're doing right now as we speak, that's only when it comes together onto one infrastructure. So that opens up a huge space of innovation. And it allows for seamless access to data and to sensors all the way from the cloud to the IoT and field level, as we've seen. Second big topic is openness. It was referred to already by Max. It's absolutely mandatory to break free from that vendor lock-in, to build on standards and replace proprietary systems. The good news is that even the industry itself has agreed upon that already. OPC UA and TSN as the two core technologies have been identified as the new standard, the new norm, the lingua franca of industrial IoT. Already late 2018, all the big vendors, like everybody, Siemens, Rockwell, Mitsubishi, Omron, Schneider Electric, you name it, like about 30 companies have publicly announced that this is the standard, the next generation to go for. So it's been decided the platforms need to be developed and rolled out accordingly, building on these open communication paths. Then the third big element is distributed computing, something that we've seen in the last 10 years in the data centers happen. It's virtualization. It's a decoupling of the hardware and the application. Basically, you don't even know anymore where it's executed within a data center. Applications can and execution can be moved freely. And this virtualization is now happening on the industrial floor, and edge computing is exactly the infrastructure for that. And when we say virtualization, it's not only some data extraction functions, but it's also at the core of what industrial automation does. It's also the controls element. It's even the safety elements, which are totally separate infrastructures on very siloed hardware and software integrated entities that can be decoupled on an edge computing infrastructure and virtualized in a way that they run next to each other. And what you get is actually the blending of this OT world, what you can see here on the left side with robustness, real time, down to the microseconds, high availability, as well as performance security, the cloud computing out of the IT space. And if you blend these two, and that should give you a very nice mnemonic image also, is it comes to IoT. And specifically industrial IoT. That's exactly what we are trying to do here. And let me already state here, Europe is, as you said, we don't play a role at the hyperscaler level in the cloud. We do play a very important role in the world when it comes to shop floors and the industrial automation space. This space is transitioning now into a new world. And if we want to stay strong, if we want to keep European welfare at the level where it is, we have to make sure that at this spot where IT and OT meet on the edge and below is something that we bring in our expertise and create very viable business models around and revenue streams. What does it mean on an architecture point of view? I will not go into detail. It simplifies the architectures, it goes seamless. And just one thing I'd like to mention is the lower part here. It requires real-time connectivity. And as I said before, the standard is out there. It's TSN that is an extension of the standard Ethernet that has been defined by IEEE that allows for real-time communication, hard real-time communication, what we need on the shop floors, on the industrial shop floor. And that is important that when you talk about edge cloud computing, that we have the connection between the different edge devices, real-time capable, also on the networking side. So TSN plays a very important role. I will not go into more detail, but keep that in mind. TSN, time-sensitive networks, are a very important element of that. A little bit on what's out there today, because not everything has to be created from scratch. Actually, I would say the technology building blocks are there. Everything can be done. It's really a question of applying it to the real-time shop floors, where we still see some reluctance to go. We, for example, have created such a platform, which is, according to the outcome of the fireside chat, it's a node software, so it's kind of a meta operating system on a node, but it has a management entity also on top, which is more the orchestration element. And I will not go into more details on that, but platforms like this exist. It's completely open. It's mainly based on open source. You can take building blocks, replace it by others. So it's very open to the standards to allow for multi-vendor and interoperability. And what you can do, just a few snapshots. There's one application like a Fels machine builder where they use it for wear detection. They do metal working, hammer on metal until it gets fluid, and they do live detection of wear with about 100,000 data points per second. There, in tremendous increase on real-time check whether that process works well or not. Another metalworking machinery, they create new IoT services for their customers and allow for remote updates for machines. So again, a case that's out there. And then there's one where Android's where they do virtual.
Look at the time a bit.
Yes. Okay. Virtualization, including firewalls there. At the edge, so that's a very important thing also, reduction of hardware. So what are my recommendations? And then I'm done. I think we should conquer that spot and make sure that Europe is strong at that, and create new revenue streams. And very concrete, I think talking about research in the future is important, but where we see reluctance currently is to get the last mile. And to really pass it on from the research labs to the shop floors and deploy these new technologies. So anything that helps accelerating that, I think, would be highly appreciated. Like even going all the way down to factory acceptance tests that can be supported, or something like export security guarantee funds. Maybe we can have something like that for implementation of IoT. And then the last thing, it's really about platform and ecosystem, also referred to a couple of times already. I think we need more cooperation of large ones and small players all together. And let's say no second thoughts about whether somebody's too small or too big, but really work on cooperating in that field. Thanks. That was what I wanted to cover.
Yes, thank you, Wolfgang. I think, there was a clear spotlight on the shop floor and control. I think you have the luxury, at least, that all the control and the different networking takes place at one location, meaning at the shop floor, and you did not expand too much on the need for going cross-sector. But still, you build on convergence between IT, OT, the paradigm, from Industry 4.0. This said, I'm looking at the third panelist, which is Christian Prehofer. We take a spotlight on the automotive. So automotive is in a very tricky situation because they have to go provide mobility on the one hand, and they have to go across sector because, with the electrification of the vehicle, they enter into the energy domain and with the different use cycles and the softwareization of the whole platform around new services. So I think they're very much confronted in many of the challenges at the crossroad of new paradigms, of new business models, and so on. And we're happy to have Christian Prehofer over here. Christian works at Denso Europe. There he is a product director for mobility services and connected cars at Denso. He's very experienced in software systems, Internet of Things, big data, data analytics, and so on. Has also a bit of an academic career. But what is maybe important also, he comes from the communication industry, from the mobile industry, where he was director at Nokia. And this said, you have seen the paradigm shift, where value moved from mobile business, mobile infrastructure, towards a new platform economy for handsets. And nowadays, Nokia is completely out of business. And the question is, can we have similar threats or several opportunities we could miss in the automotive industry, and how to manage that paradigm going cross-sector? So, Christian, the floor is yours.
Yeah, thank you very much, Rolf. Thank you very much for this nice introduction. It's a pleasure to be here and talk. I hope you can see my slides.
Yes.
Okay, thank you. So I'm talking a bit about the automotive perspective on IoT, edge, and cloud. And as you just heard from the introduction, my background is mainly in software and communication. So I also like to emphasize a bit the role of software and platforms in this meeting today. So let me start a bit with an overview slide, what's happening in automotive industry. And Rolf has already just mentioned this a bit. So everybody's talking about autonomous cars, electric vehicles, of course, connected, enabling lots of new services and moving into a kind of sharing economy. So that means a lot of change in many different places, but what is common about them is that it gets more software oriented. So all of this is kind of dominated by new software technology, and the car industry is moving from mechanical engineering to electronics now to software first industry. So you see a lot of big market players in automotive which emphasize that yes, we need to consider software first and not as a kind of add-on as it used to be in the past. And let me discuss it a bit what this means from the software side and system side. So here is a kind of high-level architecture. You have seen maybe similar thing from Max earlier today. So we have a kind of smart city with vehicles and other smart devices and participants. And then edge computing can be in different places, inside, outside the car, and then in the cloud. And let me now recap a bit what is driving these different entities here. Yeah, it's clear that in IoT devices, you have lots of sensors, lots of useful data is generated, but the problem is you have limited power by nature. So limited computing power, but also not enough energy. Yeah? And in edge computing, we are trying to address a lot of these challenges by providing more local computing power, which is also more flexible. That's also what we just heard in the last presentation. It can be more flexible, it's closer, it can process a lot of the local data which comes in place. And we need to send less data to the cloud, which is, of course, good in terms of privacy, but also in terms of data transmission. But then on the other hand, let's take a look, what are the success factors of the cloud computing paradigm in the last 10 years? And if you have used a cloud system, you know that the practical advantages are really that it's super adaptive. So if you need 10 machines, you press a button and you get 10 maybe virtual machines. And all of it is completely managed, not just the hardware, but also the complete software stack. And it also offers superb reliability, and the security is managed. And for all of this, you would need a lot of experts in your company. And that's very expensive to provide and keep alive. And last, it also provides enormous economies of scales from hardware side, but also kind of energy maintenance and also utilization. So cloud computing can be used 24 hours per day, which is unfortunately not the case for many other IoT devices. Yeah? So in that sense, cloud computing is very attractive and also difficult to handle. And in edge computing, let me emphasize two important points. So edge computing is often advertised as it's very good for local data processing. Yes, that's true, but it's also a limitation. So if you need to do access data which is not local to your environment, you need again to go to the cloud and provide a distributed solution. And of course, distributed computing is a nice buzzword and it's nice to discuss, but essentially distributed computing is still hard. It's still hard to develop distributed solutions from a software side and also to manage them properly. And that leads me a bit to the next slide about software platforms and partly about management, to show you a bit what's happening in automotive space in terms of platforms. So in the upper part of this slide, you see a bit the classic architecture of the control systems inside a vehicle. So you have hardware, software integrated from lots of different suppliers. And this integration is, of course, a major task, mainly done by OEMs and some tier ones. And in order to address this, there has been a lot of effort in the last 10 years or more on a kind of standardized platform called AUTOSAR, now in different versions, even adaptive now, to provide a kind of standardized architecture interfaces, standardized communication schemes, and standardized components. So that's also addressing the concern we heard earlier of having not this vendor lock-in, but having kind of multiple suppliers for different pieces and still facilitating integration. Of course, that leads to certain complexity if you aim standardization, but still it can provide enormous effects. On the other hand, if you look at the more IT or software side, and I think Rolf just mentioned it from the mobile phone side. So what happened in the mobile phone business is that it was also a bit of an integration architecture like in automotive. And in the last 10, 15 years, it has changed more towards open platform. So you have a big players providing a software platform, and then the actual innovations happen on top of them. And the platform providers basically benefit from the innovations of others in the ecosystem. Yeah? And this is what's kind of building strong ecosystems with also this enormous lock-in, which was just discussed in a number of presentations before. And that's happening in a number of IT sectors. It's not just mobile phones, also in IoT devices and vehicles. You can see nowadays such platforms and apps growing up ecosystems. And then let me emphasize here one point. When you look at surveys, what was the biggest thing in terms of software development in the last 10 years? And now I'm not talking about AI, because that would be what most people would answer, but actually, when it comes to about actually building systems, the biggest progress in the last 10 years is the concept of containers, which is a kind of lightweight virtualization. And why is this so important? Why can't you just run your app on a software platform? The point is that in the container, you bring all your kind of environment with you, all the libraries and other functions which you need for your specific purpose, and you get independent from the platform and its specific software platforms. And furthermore, containers are easy to manage and to deploy. And that has had major impact in how services are developed. And for me, that's an example of software first, because the focus was really on speeding up development and deployment and management of services, even though that may not always lead to the most efficient computing in terms of memory consumption and others, but it's an example of software first in the sense of speeding up development. And I think these kind of technologies are also now have a chance to move into edge computing and drive edge computing from the platform side. And I think that's one of the points I wanted to make here, how platforms are evolving in different domains and what are the opportunities to bring the more software thinking also into the IoT and edge computing. And I think with this said, I would like to conclude, and my summary would be to say, let's also consider how it is to develop applications for such distributed systems and consider the speed of development as an important factor for success in this domain. Okay, thank you very much, and looking forward to the discussion.
Yeah, thanks so much, Christian. I think that completes a bit the first round. I think there's not too much time left, so I think I will spend a bit of time discussing with you on some issues, and then I will go to the chat, and then we have to close. So, unfortunately, but I think that's maybe one important thing what I want to bring up. I think, looking at the presentation from Wolfgang, he said, well, you see convergence on the shop floor and on the control via the communication layer. I think maybe to pick up from the last presentation that as soon as the communication layer has been virtualized, I think you achieve a lot of interoperability, you achieve multi-vendorness, you achieve openness, you have this dynamics, and you follow the trend of software-driven systems, software first, as Christian mentioned. So, would this virtualization, is that also a trend in the manufacturing domain? And what sort of approaches would you see to make that happen as a multi-vendor, multi-stakeholder platform?
Yes. So yes, the reality is we see it happening, and the good news is it's not a new concept. Virtualization, as I said, in the IT space is out there, is very proven, but there are some specifics that you need to address when it comes to the shop floor. You need to make, let's say, virtualization applicable to the industrial edge. And the biggest topic of research and development, and also that one of the absolute focus points that we are addressing right now, is how to separate on one edge computing instance a hard real-time application like a controls cycle that has to run in exact cycle times, microsecond cycle times, and have a very high bandwidth consuming but non-critical application that deals with a lot of data. Think of an AI application and run next to it. And that high compute application must not interfere with the exact execution of the cycle times. And you have a similar thing in the auto, Christian, as I see you nodding there. It's even, you have to separate it also from the security, and safety. Security also, but safety functions, and have to make sure that they don't interfere with each other. So what you can take is take the virtualization concepts of the IT space, work with the hypervisor layer to make sure that you have a strong separation, that they cannot interfere, but they also can communicate on one platform. And that's exactly the focus point of the development. The good news is on the technology building blocks, there are solutions out there. It's out there. It's not like wishful thinking. These platforms exist. There's still some work to do to make it, widely adopted in the field, but the technologies exist. And I think Europe is quite strong in the research in that area. And to finish off on that, we are actually as we speak, we are rolling it out to very, large scale automotive production floors, for example, as we speak. This virtualization and including then also virtualization of hard real-time functions like controls. So it is about to happen, and it will completely turn around the way that industrial automation is done on the shop floors, and similarly in the cars. Maybe just to end with that, there's one major difference between automotive in-car and production floors that we also have to bear in mind. A car is a controlled environment where typically one OEM decides which technology goes in. So it's a better controlled environment in terms of which technology comes in. A shop floor is a very open, very diverse, also dynamic environment where machines come in, get replaced, different vendors come in. So it's a lot more necessity even on the shop floors to standardize an open standard and have interoperability built in and not created by one vendor ecosystem. So I would say that's one of the slight differences in this environment.
It's good you have that view. I think I have one question before I turn the floor to Christian again and turn it back then. But if you talk about you have to make the virtualization concepts, the multi-container concept applicable to the edge in the shop floor, do you do that alone or do you envisage partnerships on that one, or which are the ones you're aiming at?
So let me say, nobody can do anything alone here. It's too big for everybody. Even the big shots in industrial automation, no one is I would say, can do that alone. So partnerships and ecosystems are key. But that having said, I think it's also important that we kind of, each and everyone tries to find his sweet spot, and that we don't do reinvent the wheel everywhere, but everybody tries to focus on a small segment where that's the key point, and then it comes together as a bigger puzzle piece. So we are focusing on specifically the virtualization layer and how to remotely deploy that, orchestrate that. But we don't do any application, for example. It's really like an empty glass. It's an infrastructure from the software point of view that we work on. And it doesn't provide any value to the customer if you don't have the applications, then the AI applications, the things that work with data. If you have additional security measures around it, if you have the cloud where the data is then stored and processed on top of it, and also the in the industrial space, the field level, like the IOs, the sensors and actuators that actually do the job there. So it's a very thin layer that we focus on, and I would really argue that nobody, not even the Rockwell, Siemens, Mitsubishis of this world, are big enough to do all of that alone. And it's crucial to have a very vital ecosystem. Of course, competition is important, but let's really not reinvent everything all the time. Try to, orchestrate it in a way that it comes together and creates the bigger picture altogether.
Okay, I think I would have questions, how to create the bigger picture, steered by, orchestrated by European players, but I think we don't have the time. I want to go back to Christian first, because it was said, well, the car is simple, because the car OEM can decide what sort of components will be integrated. We heard recently from Volkswagen and Daimler-Benz and BMW, we need a new framework, a software framework, an operating system for the edge. What do you think about that?
I think it's clearly a big challenge in automotive to balance the need for fast innovation and at the same time for safety of riders. And it's also clear that there is no perfect solution yet. Yeah, and it's of course a balance in what aspect you're using edge computing. So like Wolfgang said, it was maybe more in a partly real-time environment, and in automotive you have maybe different levels. You may have edge computing, which is touching more the real-time front, and maybe you have also more infotainment or other services which are less real-time sensitive. So it's a bit of a continuum, and it's clearly a challenge, and that could be definitely an important step to get an industry agreement on such a platform, which can be used in this continuum.
And do we need a new operating system for the edge, for the automotive, or is that?
I mean, we currently see a bit of inflation in operating systems, yeah. But I think there is clearly a need. But if you look in more detail, most of the systems are reusing some of the pieces, and some of the pieces also from my slides. Yeah? So things are not completely reinvented here from scratch. That's also not realistic, but kind of agreement on a common operating platform, yeah, would certainly be a major step forward. And I think that's a bit the challenge in the industry now, that basically the industry was built around the components inside the car. Let's put it like this. And that also was the structure of the industry. Now with everything becoming software centric, also the roles of the players in this industry are changing a bit. And such a kind of standardized platform can also be very helpful to accelerate the market and to create healthy competition inside the sector. Yeah.
Okay, thank you. I think we'll not close before giving a word to Petter. I had a late night chat yesterday with the Linux Foundation. It's always a bit busy, difficult with this American people, to have a chat. But anyway, but it was clearly said that going to the edge, none of the electricity providers have the means to do sort of that the system design of today is prepared to deal with the dynamics of the market driven by electric vehicles and renewables in the future. Would you subscribe to that?
Yes. Actually, that's the big challenge we have to go, and that was also the plea which I did in my presentation. That the only way you get around that is you sit together and you work it out together, and then you should do it in such a way that is also economically efficient, because at the end the cost is for the end customer. And I said in the Netherlands many times, we cannot afford it to go to the end customers and say, may we have another billion euro because we're going to replace all the smart meters again. So we have to work together in a smart roadmap and build this together. And then at least coming into edge computing, where also vehicle to grid is implemented, as I said earlier. Only together it will work, and therefore I think we really should focus on how we do it. And then the question of what we do will come out from itself.
Yeah, though I think maybe some homework for you, then you think about these virtualization concepts, which do not happen in the energy domain yet, particularly not at the edge, which is multi-vendor, which create a new opportunity. But this said, I want to focus on the question from the chat, and which is on IoT is about data and access to data, and how do you deal with the protective tendencies and the rigid policies at European level on data management, data governance, and how would you see that across industries particularly?
I can only give the answer from my experience in the Netherlands, because we saw that protective tendencies in the Netherlands as well in the beginning. And the only thing to come around that is that you found out which are the relevant people, and you sit together in one room and you start to talk about it, and you get some trust level to each other, and then you start to work together on this. This is the only way. And of course, it's not a free discussion. So in the Netherlands, also the Ministry of Economic Affairs was involved, as they at that time were starting to implement the clean energy package. So actually, what we came across with the sector and all the parties involved will now also be addressed and implemented in the Dutch upcoming Energy Act on this. So it's not a free thing. There is some obligation in there. But the first point is, let people sit together.
Yeah, I think that's one of the main things. And as you mentioned, the Afsprakenstelshold, to get an agreement on data sharing, data access, and data governance across industry, I think that's one of the key building blocks in order to steer the discussion and get the agreements and provide the services for the customers and the end users, because end users have no problem to share the data in Facebook. So why not sharing the data with an automotive company or an energy company with an electric vehicle if they get the right level of service?
In the Netherlands, we have now already the banking sector who's very interested in having some of the energy data because they can provide cheap mortgages or loans for isolating the homes. Also, building corporations start to, and so we really start to create wider coalitions as only within the energy sector itself.
Sorry, guys, if I interrupt or I jump in, but we have to mind a little bit the agenda and timing because there are speakers for the next session that are waiting for us. So Rolf, maybe if you can wrap up the session and we give the floor to the next one.
I think it's quite difficult to wrap up. I think we started off with the challenges, to have the right level playing field at the edge with the new role of the edge. On the one hand, with the cross-sector integration, on the other hand, with the interoperability and the governance across more and more software-controlled systems to keep the level of safety, security, and privacy, while at the same time have an open vendor environment. We did not go much, to see, what are the next steps, but I think some basic concepts, technical concepts like virtualization, would be around to steer some of the developments, as well as take account on convergence of the different technologies between IT and OT to have the new next generation of IoT, industrial IoT, and control systems levels, but also as a baseline eventually coming in the midterm and the long term for cross-sector integration between the energy system, the mobility system, but also the home and living and the renewables. I think there's many open questions still, but I think that was the main purpose of the session.